Good morning, good afternoon, or good night, Dr. Aisha. I am Rishikeshan 2230327, and I'm going to present to you about our group project assignment. These are our team members. First of all, Shaktiswari, the person there. And next is Varunish, person here. And next is me, Rishikeshan, and Shashwin Nair is there. Today I will be presenting about modeling linear programming problem using Microsoft Excel Solver. This study, which we are doing, demonstrated how Microsoft Excel Solver is applied to linear programming problems. The study considered an illustration culled from Akbadudu 1996, a tailor making two garments, a dress and a suit, with three constraints, which are three resources, namely cotton, silk, and wool. Microsoft Excel Excel Solver was used to find an optimal solution to the problem of resource allocation confronting the tailor. Further analysis were done using answer and sensitivity reports to provide robust solutions that can serve as a guide to the tailor in making appropriate decisions. Scenario analysis using data table, a what if analysis tool in Microsoft Excel 2007 version was used to generate possible profits that the tailor can make from producing different units of garments, dress and suit. It is found that the tailor can produce 70 units and 20 units of dress and suit respectively to maximize profit based on the resources at his disposal, while the maximum profit of the tailor can get for the given period is 14,500 naira. It is therefore recommended that business owners, managers, and students should be exposed to the knowledge of linear programming problems through the use of computer software such as Microsoft Excel Solver, so as to enhance their decision making skills.
I am 2230328, Shashwin Nair Chandran. I will be explaining about the research paper that was chosen. So the research paper that we chose for our assignment is modeling linear programming problem using Microsoft Excel Solver. So as from the previous research that was done, the study was demonstrated using Microsoft Excel Solver and was applied to linear programming problems. So it was taken over by us, and we are here to actually explain the problem and what media we're going to use to solve the problem. So the problem in this linear programming is a tailor has the following materials available for production of dress and suit: 160 square meters of cotton, 110 square meters of silk, and 150 square meters of wool. A dress requires the following: 2 square meters of cotton and 1 square meter each of silk and wool. A suit requires 1 square meter of cotton, 2 square meters of silk, and 3 square meters of wool. If the profit realized from a dress and a suit is respectively N150 and N200, how many each garment should the tailor make in order to obtain maximum profit in the period under consideration?
A very good day to you, ma'am. Today I'll be explaining about the Excel solver for our LD project. So first of all, as you can see, ma'am, we are creating a table for our decision variable. So our first decision variable will be a dress, and then we will add in our value. And then our second decision variable is the suit, and the value is 20, we added that. And then our first coefficient will be coefficient of x1 dress, we'll add in the value. Then coefficient of x2 suit, we'll be adding in the value as well. So next comes our objective function, z. So we've used short keys here actually. And we have our value. And then lastly, we'll have our constraints. First we'll have our button, and then we'll have our seal constraint, and then our wool constraint lastly. Now we will prompt the Excel solver. So now we will set the objective function first to a maximization problem, maximize. And now we'll be adding our constraints. Now we'll determine whether it's less than equals to or more than equals to. So we'll set the universal constraints first, which is more than equals to 0, and then we will add the cotton, the silk, and the wool constraint to the solver by adding the inequality and the value. Now we'll determine the solving method in the solver, and then we will solve, and the solution will be presented by the solver. That's all from me in the part of Excel solver. Thank you, ma'am.
Today I'll discuss about the simplex method calculation, which is done manually. First, we need to create a table based on the question given. From the table, we need to find the objective function, constraints, and also the decision variables. The objective function for this question is maximization z equals to 150x1 plus 200x2. And the constraints are 2x1 plus x2 less than equals to 160, x1 plus 2x2 less than equals to 110, x1 plus 3x2 less than equals to 150, x1, x2 more than equals to 0. And then the decision variable for this question is x1 equals to production of dress and x2 equals to production of suit. From the objective function and constraint, we need to create a simplex tableau. So this is the first simplex tableau of us. From the simplex tableau, we need to find the pivot column, pivot row, and also the pivot number. First, pivot column is the highest value of Cj minus Zj. So for this table, the highest value is 200. So the pivot row is x2. For the pivot row, the minimum value of ratio, which is 50. So the pivot row for this question is S3. So the intersection is the pivot number, which is 3. Next, this is our second simplex tableau. For the pivot column, x1 is our pivot column, S25 250 over 3 is the maximum value, and then S2 is our pivot row, as the ratio is 30, and then the pivot number is 1 over 3. This is our third simplex tableau. The pivot column is S3, which is the maximum value 100, and then the pivot row is S1, which is the minimum value 20, and then the pivot number is 3. This is our optimal solution, optimal simplex tableau. It's because Cj minus Zj should be less than or equals to 0. So here our value is 0, 0, negative 100 over 3, and then negative 250 over 3. So this is our optimal solution for this question. Since Cj minus Zj less than equals to 0, hence optimal solution is x1 equals to 70, x2 equals to 20, and z equals to 14,500. That's all from us. Thank you.